Hello friends, welcome to Learnest video series on mathematics. In this video, we are going to start off our second chapter, that is polynomials. Now you have already learned quite a few things about polynomials in your previous grade. In this chapter, we will take that concept a bit forward and try to gain few more insights about polynomials. So let's quickly revise what you already know about polynomials. Make sure that you take active notes while revising these. Now that you are ready, tell me, what do you mean by polynomials? Poly means many and nomial means terms. So basically, polynomial is an algebraic expression that has a combination of various terms. These terms could be a mix of variables and constants. Here are a few examples of polynomials. If the expression has only one variable, let's say x in it, it will be known as a polynomial in single variable x. And some of the examples of polynomials of single variable is 5x plus 7, 6x squared plus 5x plus 3, etc. Now, can you spot coefficient in these expressions? For the first example, that is 5x plus 7, 5 is the coefficient of x. In the second expression, 6 and 5 are the coefficient of x squared and x respectively. In general, we can call these as p of x, meaning polynomial in x. If the expression has only single variable y in it, we will call that as polynomial in y or p of y. Now observe that we could even have polynomials with more than one variable in it. For example, consider this expression. This expression has two variables x and y in it. So we call it polynomials in two variables x and y, or simply p of x, y. This expression on the other hand has three variables in it, x, y and z. So we call it a polynomial in three variables x, y, z, or simply p of x, y, z. In this chapter, our focus will only be on polynomials in single variable. Now recall that there is something known as degree of polynomial that you have learned in your previous grade. Let's look at some of the examples to have a clear understanding of what you mean by degree of polynomial. Consider this expression, 5x plus 7. The highest power of x in this expression is 1. So we say that 5x plus 7 is a polynomial in a single variable x with degree 1. This is also known as a linear polynomial. General form of linear polynomial is ax plus b, where a and b are real numbers and a is not equal to 0. Now consider this expression, 6x squared plus 5x plus 3. Can you tell what is the degree of this polynomial? The highest power of x in this expression is, yes, you got it right, it's 2. So we say that this is a polynomial with degree 2. This is also known as a quadratic polynomial. Quadrate means square and hence the name quadratic polynomial. Now can you write down the general expression for a quadratic polynomial? It's very simple. The general expression for a quadratic polynomial is ax squared plus bx plus c, where a, b and c are real numbers and a is not equal to 0. Similarly, we can have cubic polynomials. And how would a cubic polynomial look like? Consider this expression, 7x cubed plus 9. Now this is a polynomial with degree 3, right? So we call it a cubic polynomial. The general expression for a cubic polynomial would be ax cubed plus bx squared plus cx plus d, where a, b, c and d are real numbers and a is not equal to 0. So what does all this mean? It means that as we increase the powers of x in an expression, we get higher and higher degree polynomials. Now we can write the general expression for any polynomial in single variable x of degree n as an x to the power n plus an minus 1 x to the power n minus 1 plus etc. a1x plus a0, where a0, a1, a2, etc. an are constants. Also notice that an is not equal to 0. What happens if an is equal to 0? You can easily see that if an becomes 0, the entire term an x to the power n blows off and it will no longer be a polynomial with degree n. Also notice that all these exponents or powers of x has to be a whole number. That is, it could either take value 0 or any positive integer. Now some of you might be thinking, for a polynomial of degree 9 will have these many terms, such a lengthy expression. But understand that it's not necessary to have all these terms to call it a polynomial of degree 9. The only thing that we need to ensure is that we have that term a9 x to the power 9 to call it a polynomial of degree 9. For example, consider this expression. See, many terms are absent here, but still it's a polynomial of degree 9. So it's okay to have a higher degree polynomial with fewer terms. We can deduce from this expression that a9 equals 9, a4 equals minus 5 and a0 equals 12, and rest of the coefficient will all be equal to 0. In general, we can say that for any polynomial p of x, the highest power of x in p of x will be the degree of that polynomial. Now one last thing before we wrap up this revision. Do you think these expressions are polynomials? If you observe carefully, for example, take the first expression, root x plus 5. Now root x plus 5 can be written as x to the power half plus 5. Notice that the power of x here is half. It's not a whole number. Hence, it will not be a polynomial. Consider the second expression, 2x plus 1 by x squared minus 5. Notice the term 1 by x squared there. 1 by x squared can be written as x to the power minus 2. Since this expression contains a x term that has a power which is not a whole number, we cannot call this expression also as a polynomial. So, to identify a polynomial, all you need to check is whether the power of variable term is a whole number. Now try to answer this simple question. Is 5 a polynomial? Think about it. If you think about it, you can see that 5 can be written as 5x to the power 0. Which means we can call 5 as a polynomial of degree 0. In fact, if you just have a constant term and nothing else, you call it a constant polynomial. A constant polynomial 0 is known as a zero polynomial. Also, make sure to note these two important information about constant polynomials. Degree of any non-zero constant polynomial is 0. Whereas degree of a zero polynomial is not defined. So that's it guys. It was a quick revision of what you have already learned in your previous grade. In the next video, we will learn how to find the value of a polynomial and zeros of a polynomial.